Hey guys, this is Oscaler UP, otherwise known as Zachariah, here on YouTube. Today, I got this Union Pacific caboose here, and I'm sick and tired of this caboose flickering as it goes down the track. So it's got the LED lights in there, Lionel put in there, but there's no capacitor. So we're going to go ahead and take it apart, put a capacitor in there. Just as a fair warning to everybody, I'm just kind of doing this as I go along. It's not going to be the best video. If you have any questions, make sure you just leave those down in the comment. I may not explain something completely. Like I said, this is going to be just kind of me going along, learning myself on how I'm going to go ahead and accomplish this. Let's get into it. One last quick note here before we get started. I just want to give you a warning. My dog likes to come down here sometimes. She's kind of loud. Forgive me for that. There's nothing I can really do. I don't see a point in locking her upstairs. So just fair warning, you hear some weird loud snoring pig type thing. That's my dog. Also, as you can tell, my kind of work table area here is a mess. It's nothing too crazy, but it's functional. Like I said, it's that's all it needs to be. So it's a mess. That's just how it is currently, and we'll go ahead and start on our little project here. Okay, so before we go ahead and take this apart, let's kind of talk about our game plan here on how we're gonna do this. So this is just kind of a rough schematic here, and we're gonna try this full bridge rectifier here. Not sure if that's gonna be necessary with as little current as we're pulling. So we have, so there's that there, and this particular one, there's two capacitors in there. Kind of hoping we can get away with one, but you know, who knows? We can add as many as we want. We'll have a resistor in there because when we put in our rectifier, remember Lionel transformers always peak at a around 20 some odd volts on the AC sine wave. So when these capacitors charge up, they're going to charge up to about 20 volts or so, and we don't need to be sending 20 volts DC at that point to our LEDs. Right now they run off 18 volts AC, so they're actually only on half the time with that AC sine wave at this current point. So when we put this in here, we're going to have to drop our voltage. And then right here we have a Zener diode, and we're going to use that there to control our voltage going to our LEDs, and that's just so we don't get a random spike and possibly burn out those LEDs. So that's our plan there. So right here is a bag of some 1N4004 rectifying diodes, and this is what we'll use for the rectifier. Like I said, we'll try a full bridge rectifier. Not sure if that'll be necessary for as little current as we're going to pull, but those are our rectifying diodes. And right here we have our Zener diodes. Like I said, this is what's going to control our voltage for the power going to the LEDs. That way we don't get a random spike. And these are 7.5 volts. So the board on the inside of the caboose actually has a couple of resistors already on it. So that's what we need to give power to. We don't need to drop it all the way down to like 3 volts for the actual LED, because there's already resistors on the board for that. But this will keep the DC voltage going into that board at a 7.5 volts. So there's those. And I got a couple different capacitors here. So these are two 1000 microfarad 63 volt capacitors. Probably didn't quite need 63 volts, but I wanted to be safe if I used that full bridge rectifier and if it increased any voltage. And here's some 50 volt 470 microfarad capacitors. I also have, this is the first one I tried, just had this laying around. This one's a 40 volt 330 microfarad capacitor. Obviously it's bigger than my 470s, so probably won't use it since I can get a little bit more capacitance out of a smaller capacitor. And something else always good to have is going to be resistors. So I have a whole bunch of different types to kind of match what we're going to end up using. Those are 887 ohm. These are 820 ohm. Those are 100 ohm. That's a 3.3k ohm. I had a 1k ohm resistor around here somewhere at one point in time. But all kinds of different resistors. Not sure what we'll need for this particular project here. And something else kind of keep in mind, these are little 1k trim pots. So essentially, just like our volume pot on our engines, but in this case what it's going to do is it's going to act as a variable resistor. That way we can add this in there as the resistor at first, and then we can just go ahead and turn this and trim it to the voltage and brightness that we like, and then just measure this and figure out what resistor I need to go ahead and put in there. So there's that. And then last but not least is going to be wire, because we're going to have to add all these components in there, and we'll need some wire. This is way too thick. I originally picked this up, and something tells me it's going to be a pain if I try to use this. This is 18 gauge stranded wire. Crazy overkill for what we're doing here. So I would probably recommend this here is 24 gauge stranded wire. This ought to work just fine for what we're doing. If it's still a little thick, you might try 26, but I don't know if I'd go much lower than 26. Like I said, I believe this is 24, and this is probably what I'm going to use. So there's that. Let's go ahead and get into it. Okay, here I got the caboose all torn apart. Didn't take a picture or anything when it was put together, but as we know, obviously it was wired in directly with our 18 volts AC from the track, because the thing flickers like crazy. If anybody was wondering, so originally this is the switch off the bottom of the caboose. This wire here goes to this is our ground to our LED board here, and the other side was originally our ground wires from the trucks, which I have over here. And then our hot wire coming off the board was originally just soldered straight to our hot wire coming off our pickup rollers. So what I have here is some of the first stuff I had just laying around before I got to the electronics store. So what we have set up here, this is the first one that the first setup I got that worked worth a darn. So right over here we have our 1N4001 rectifying diode. So that's cutting down our AC sine wave to just the top half. So now we're getting a DC current, and that feeds into our capacitor here. And over here I got our hot side of the of our board. So this is our pickup rollers, goes into the diode, and we come over here to our LED board, and it also starts charging the capacitor. This is just a 330 microfarad 40 volt capacitor. Again, it was something I had laying around. It's kind of big. As you seen earlier, the 470 50 volts that I got from the electronics store are a little bit smaller. Different manufacturers, different packages for the capacitors. So I'll probably use one of those in the end, but this is just what I had originally set up to mess around with. So there's that, and then off the other end of the capacitor, here's our ground. Ground goes up here and charges up the capacitor fully. And our ground off our board comes in off the switch, so we can still turn it on and off. And then we run through a 1K resistor is what I've found so far that works nice. So Lionel transformers modify the sine wave. I have a ZWL hooked up right now. And what that's going to do is, if you actually take a voltmeter, which I'll do here in a second, I'll have the transformer up all the way, and we'll get 16 volts on the track, but actually it peaks at about anywhere from 18 to about 24. I've read 24. And then as it comes back down, that's how we get our constant voltage on our track. It's I may not be exactly correct on that, but nonetheless, our sine wave peaks at 18 and or above ish, and that's just how Lionel has designed their transformers, and it works really well with their trains. But anyway, that's what I have on here right now. I'll try a regular transformer with a normal AC sine wave here in a little bit after I get all this figured out. Make sure it still works that way. And so what I'll do is find a remote over here. And go ahead and apply track power. Of course, everything else turns on too, go figure. And there turns on our LEDs. So, like I said, here's the legacy remote. My ZWL's up all the way. So, if we were talking normally, we should have 18 volts on the track, right? So here is, now, bear with me, I'm kind of cheap. That's just a little Harbor Freight multimeter, so it's not like it's nothing fancy. We'll come over here, and I'll can't really see where I am because I'm off to the side, but this is track voltage, so we're actually getting 16.4 volts on the track. And now what I'm going to do is we're going to flip over to DC because I got that rectifier on there. And come over here. See if I go on to, if I hold it in the right spot. Hold it right there. See, now we can see after we've got that capacitor charged up and after that rectifier, we're getting actually 23 volts DC. And I think, again, that's because that sine wave is peaking up there, and we got that top half of that sine wave. I can't hold that. There we go. But anyway, you've seen that. So we're actually getting like 23 volts DC. We don't need that, obviously, because with that AC sine wave, our LEDs were flickering 60 times a second. Not that we could see that flickering. But now that flickering's out of there because we're a direct DC voltage. So now, I'm going to move this over here. Hopefully you can still see that. Now, if I come in here, put my ground right here. If we come over here, we can see I actually only have about 5 volts DC going to that board. Oh, okay, 7-ish. And seeing this now again actually might be a little dim, but the issue is I don't know what these LEDs are rated at, so last thing I want to do is make those blow up. But anyway, they're on. That's all we know right now. So I'm gonna go ahead and kill track power here real quick. Well, okay, yeah, we'll kill track power here real quick, and we can see a nice ramp down of those LEDs. We'll go ahead and bring her back up. Have it all nice charged back up. And go ahead and kill it again. See, we have that nice ramp down, which is what we're looking for. That 330 microfarad capacitor isn't bad. Figured 470 wouldn't hurt. Those other ones from the electronics store are a little bit smaller, so that'll make it easy. Kind of hoping to maybe get something shoved up in this here area. That way we can hide everything. Okay, so now I kind of changed some stuff up again, and I figured we kind of take a look at this. I went ahead and I put in the 470 microfarad 50 volt capacitor. I probably should have seen about getting a bigger one yet to see if it, see if it was too big. I'll show it to you guys here in a second. I just tried it. It's better than the 330, but another step up. May have not hurt. Kind of hard to notice the difference on the 470 compared to the 330. But you know what? It's still a whole lot better than seeing these lights flicker like nobody's other going down the track. So what we have going on here now is I got that in there, and then I went ahead and I put in one of the 1K trim pots. So what these are is those trim pots allow us to, more like a variable resistor. So turned up all the way, it's a more or less a 1K resistor like I had in there. But we can turn it down, and as I turn down that resistance, my voltage is going to increase to that board, and consequently our LEDs are going to get brighter. Again, catches with that is I still don't know what the rated voltage for those LEDs is, so we're kind of playing a guessing game here. I do have this other caboose. This is the it'll be kind of hard to get both of these in here, but we'll try here in a second. Give me a second. Scoop that down. Okay, that ought to be enough for you guys to see. But I have the big boy commemorative caboose. This one has the exact same LED board in there, wired in direct, so it flickers like nobody's other. This one has a smoke unit, so hint the reason why I didn't take that one apart first. A whole lot more going on inside there. But I got this one apart, and we'll go ahead and apply track power again. So it's kind of difficult to figure out what brightness everything's supposed to be at, because of course this LED's out here and that one's in there. Right now I believe I have that trim pot turned up all the way. I'm gonna kind of get my hand in here. I'll come around to the other side. Camera while I'm at it. And we'll go ahead and turn this down. Oh, never mind. I lied. Okay, so that's up. That is the full 1K. I lied. I was messing with it earlier. So that is that full 1K resistor, essentially, that I had there earlier. And that's probably pretty close to where that one is, but we could probably go a little bit brighter, right? So we can turn it up, and we can turn it up all the way. See, there's that full 20 some odd volts. We don't want that. So, something around in this here ballpark area probably isn't bad. And it's a little bit less than that 1K that I had in there earlier. But there's the 1K trim pot. One thing I did not note on the capacitor, oops, sorry. Let me go ahead and kill power. You guys can kind of watch and see how that, how this 470 lets those LEDs ramp down. Again, not bad. Still a whole lot better than just turn off right away. But so on the side of our capacitor, let me grab a different capacitor. Here's that 330, my favorite capacitor. So on the side of our capacitor, we're going to have either a positive or negative type deal going on here. See, on the 330, there's plus signs on this side. So this lead here is our positive. And we always want to make sure that our positive is going to be R1 right there after our diode. And our negative is obviously the other one, and that's where we're wiring in our direct ground and our feedback from the LEDs. So there is that. Okay, so I played with the trim pot a little bit, and now we're down. I got it cranked down to about 500 ohms. So if I come down in here, we can see that. Of course, I can't hold anything. But yeah, like you've seen on there, it's in like 495 or something like that. It's about 500 ohms. And I kind of like that a little bit better than the 1K we had earlier. So let's go ahead and apply track power. And I finally took off the Vision Line Challenger. That was the buzzing noise you always heard when I applied track power. The coupler likes to fire every time you add track power. So I finally took that off the track. And so here we go. And go ahead, and here is our ramp down. We shut off power off, cranks down. So one thing to keep in note is as we take down our resistance, we're going to be using more of that stored energy that we have in the capacitor, so we're not going to have as great as a ramp down. So I might end up back at the 1K, but for right now we're playing with about 500. Go ahead and apply track power again. And we'll crank us over to voltage, DC volts. And what we're going to do here is I'm going to put this here. We're going to come up here about right there. Nope, I went there. Sorry. I could just figure out where I wanted to set the test probes at. Hopefully you can see that we're about 10 volts is where I'm over here at a good connection. So we're about 10 volts now instead of about 7. If I remember correctly there with the 1K. A little bit brighter. Again, our capacitance isn't as great. And like I said before, don't know what these LEDs are supposed to be at, but this is kind of a starting point. I'll kind of try to compare with that Big Boy Caboose and see where my brightness levels are at. That's what I'm going to kind of go off of. But also keep in mind is Lionel's got surface mount resistors for each LED on here. So we're going in 10 volts, but after that, before it hits the LED, it's actually being hit with a 1K resistor, is what those surface mount resistors are. So, our voltage is getting ramped down even more. But so that's that. Here, real quick, I'm going to go ahead and I'm going to unhook the ZWL, and I got this old Lionel 1033 transformer. I'm missing a handle, so I just got the orange handle. I need to go get me a replacement black handle. But I'm going to hook that up, and we'll see if this is going to put out a normal AC sine wave. So we're going to see if that actually makes a difference between our voltage on the board or our brightness level or anything like that. So let's hook that up real quick. Okay, so I got the 1033 hooked up, and let's go ahead and check our track voltage. Get my big hand in the way here. And so we'll check track voltage. We are actually, out of that, we get about 15, almost 16 volts. So a little bit less than we was getting out of the ZWL constant track voltage. And we'll go ahead and flip on back over here to DC. So over here on our board, we're still at our 500 ohms on our trim pot. So now we're actually only about 8 volts. Earlier we was about 10 with the ZWL, so it makes a difference. Is it enough difference to cause concern? I'm thinking no. The only way to combat this is either 1, guarantee you'll always have one type of transformer, or 2, put one of these trim pots in there, drill a hole through your frame, and do it that way. And that way you can adjust your resistance according to whatever power supply you got. But let's go ahead, just out of curiosity. So earlier we had about 23, 24 volts DC straight voltage when the capacitor is charged. So here we have a 18. So that capacitor charges up to about 18 volts. So that's that. Let's go ahead, and I'm going to go ahead and crank this. So that's our 500 ohms, right? Let's go ahead and crank this trim pot up. all the way, so that'd be, since it's a 1K trim pot, that's our 1K resistance, and see what kind of voltage we have now. So if we kept with our 1K resistor, earlier we had what, 6, 7, now we're only about, or no, it was almost 7, now we're about 6. So like I said earlier, I'm thinking it's not too big of a worry. That'll be personal preference later on down the road. And so I'm going to kind of play around with this, figure out what resistance I like better, and we'll start setting this together, and we'll have us our flicker-free lighted caboose. Okay, so this has been my best working circuit so far. This is probably the only one you'll see because a lot of the other ones looked really ugly, and I didn't get them presented very well. Of course, this one isn't great by all means, it's just functional at this point. So right now I got my switch through my AC hot. If I remember correctly from the factory, this was actually AC ground, believe it or not. So I went ahead and put our switch on the AC hot here. After that switch, we have our little rectifier. Just a single rectifier works just fine. After it goes through the capacitor holds up to, the 20 some odd volts or whatnot the ZWL spikes at. After that, then we have our capacitors. A 1000 works okay. It is kind of big. I went ahead and add a second 1000. I put that on there. That looked really nice. Don't have room for two 1000s. It'd be really hard to. The only way you can do it is if you camouflage them, and it'd be really hard to do that. So I went ahead and I got two 470s on here along with the 1000, and that looks really nice. I'll just turn it on here in a second so you can see it. After that, we have a resistor. If I remember correctly, this is the 820-ish. I'd have to double check my circuit. I'll let you know exactly what resistor I use. Of course, that's going to depend on each and every different circuit. Is going to need a different resistor. So that's why the trim pots and potentiometers help a lot. That way you can hone in on what resistance works best for you. After that, on our hot side anyway, we have our little Zener diode, and this is what's going to regulate our voltage. This resistor actually keeps it around down about 7. The Zener is at 7.5, and what that's going to do for us is that just in case something funny goes on, we gotta really get a spike of voltage come through here, and then we're all of a sudden above 7.5. That Zener is going to purposely keep it at 7.5. That way there's no possibility that I can burn up any of these LEDs or anything like that. On a return side, again, our Zener kind of jumps across between positive and negative. Come back around, ground off our capacitors, and that goes off to our AC ground. This seems to work the best. We've tried a full bridge, full wave rectifier. It worked for the amount of current we're drawing. It wasn't necessary. There's no reason to put 4 diodes on when one works just fine. So that's what we got here. Go ahead and turn it on. And there we can see I'm all the way up at 18 volts on my ZWL, and there is our light. And go ahead and just kind of tip it off. You can kind of see it kind of pick up. That way, if you hit a dead spot going down the track, that's probably what you'll see. Something about like that. Probably really kind of hard to see in the video, but not a whole lot. Go ahead and kill track power. When I hit 0, it'll go to 0. Track power's off, and we have a nice good ramp down. So I think this is what I'm probably going to go with, and I'll kind of get it sorted on how I'm going to fit it into the caboose. I'm probably going to put that 1000 sitting here, one of these 3 spots. I'll probably paint it brown or something and kind of try to camouflage it on the inside of that caboose. The 470s will fit right in here really nice, and try to shove that the diodes and the resistor down one of these holes here, or maybe they might just lay flat just fine. So that's that. Like I said, I'll try to figure out how I'm going to make all that fit, but I think that's going to be my best bet so far. Yep. Okay, I finally got everything put together, and it actually works. I just wanted to go ahead and show everybody how I got all this mixed up in there. Hopefully I can get the screws in and nothing's bound up or anything. But right here is actually the 1000 microfarad 63 volt capacitor. I put some silicone there to try to hold it. Obviously I kind of tried to paint it to kind of camouflage it. I ain't the best. I mean, it didn't look great, but it didn't look like a capacitor. If you're not looking for one anyway. It's, like I said, I ain't the greatest. Anyway, and then if I flip this up, underneath here, inside these two compartments, I got the two 470 volt, two 470 microfarad capacitors hid up in there, and that's where those are hiding. I will say, like I said before, I kind of been filming this as I go, and originally I'd only got an 18 gauge wire. That is way too thick. It was way overkill to begin with, and trying to get all this stuff in tight places, there's some stuff in here that is still 18 gauge because I didn't feel like going back in there and fixing it, but all this white stuff here is 24 gauge wire and 24 stranded gauge wire, and that is probably the biggest you'd want to use. You could probably get away with some 26 in there, but 24 is probably is a good place. I mean, all we're running is a couple, 4 LEDs. It's not like we're pulling a crap ton of current or anything. And if we are, there's an issue. So anyway, a couple of things I did here. So this wire here is our center rail power. That comes up to the switch. So that way I'm actually, if I decide to turn it off, my switch is actually killing AC hot. If I remember correctly, when I took this apart, Lionel actually had that on ground. It was actually killing AC ground, which to me I thought was odd. Just, it's a switch. Whatever works. But I've preferred to have it kill AC hot, so that's what I did. And after that, in this piece of heat shrink right there is my rectifying diode. And I don't think I have one laying out close to me to just kind of show you the diode again. But anyway, that diode's in there. And at this point, I don't remember which direction that diode's supposed to sit in there with the line. If I already mentioned it, I mean, that would be correct. If not, that diode, just kind of set it on, your track or a transformer or something, and if you get voltage, then basically it's going to work or it's not going to work. It's going to be the deal. So if it works, you have that diode hooked up to your hot, and put a lead on the other end of the diode, and your other lead to your AC ground, which would be the same as your DC ground in this case. And as long as you have a correct voltage, you're good to go. Your meter ought to say either positive or negative. If it actually says a negative voltage, then you got to flip your diode around. Anyway, so after that, my hot power then runs up to the 1000 microfarad capacitor, then jumps from there to this 470, jumps down to that 470, then the hot power comes. It was hard to get heat shrink up in there, so everything's kind of taped up. But in here is my, from the hot lead off of this capacitor, is my resistor. I think I finally went with it's like 800, maybe 820 ohms, about that ballpark area. That seemed to give me a good constant voltage. And then right after that resistor is my Zener diode. So, and then off that same side, right, our Zener diode, I got a schematic over here. This is kind of for a different deal. So I have 3 capacitors instead of 2, and I didn't use that full bridge rectifier. I only used 1 rectifying diode. So this isn't exact, but anyway, there's a resistor, and here's our Zener diode. So comes off the resistor, goes on the Zener diode. Then I also have to solder on to that same side of that Zener diode, and that goes off over here to our lights, and that comes up here, and there's our plug. And then on our negative side, same our AC ground just comes straight from here, goes up to negative side of my 1000 microfarad capacitor. That jumps down to this 470, then that 470. So we come down along here, and then got to put a wire from there to the other side of our Zener diode. Then from there we can go on to our up here to our wiring harness. Hopefully that makes sense. I just thought I'd kind of try to show everything before I put it back together. I'm going to go ahead and screw this back together, and we'll see how it looks with the caboose on there. This is taking me a while to put together, but hopefully this ought to look really good. I got another caboose, the Big Boy commemorative caboose. It doesn't have any capacitors in it, but it's got the same lighting board. The only difference is it's got a smoke unit. So I think I might have mentioned it before. That's why I took this one apart. That way I don't have a smoke unit or anything to deal with inside here, to kind of get an idea of what's going to take. This may not be the simplest idea, or way to do it, but currently it seems like it's going to work. So I'll put this back together, and we'll kind of compare it to that Big Boy commemorative caboose and see how well it works. Okay, I went ahead and I got that caboose all set back together. I pulled out my other caboose here. That way we can go ahead and kind of compare the light brightness and go ahead and see how that looks. Go ahead and turn on track power here. There we go. We're at our full 18 volts. Might be kind of hard to see with the light on currently, but from what I can tell now, I think this one here that I have the capacitors and everything in there, I think it's a little bit dimmer than it probably than its counterpart over here on the left, which probably tells me that those LEDs are probably about a 3-volt LED, and I think if I remember correctly, we were with this resistor that I have in here now, we were getting around 2.7, 2.8, somewhere around that ballpark area. So it might be a little bit dimmer. So that's something to keep in mind. That's just, again, that's something that's just this particular caboose. Anything else you try to go put the circuit in, that resistor is going to have to change for whatever you're powering. It's going to be dependent on what you're trying to accomplish. I'll go ahead and we'll turn out the lights, and we'll kind of see if we can't take a closer look. Okay, so again, this might be, I don't know how well this is going to turn out in the video, but again, our caboose with the capacitors and everything's on the right. My other caboose is on the left, and again, it kind of seems like that the caboose, we put that in, capacitor and everything in, it does seem like it is a little bit dimmer. Go ahead and kill track power here so we can see that ramp down. We'll see the one on the left turn off automatically. And we have a nice good ramp down from the one on the right. Go ahead and pull that back on. And see if we get some flickering. Yeah, see, we got some flickering out of that one on the left. Some, not a whole lot, I guess. But our one on the right stays perfectly lit, which is what we were trying to accomplish at the very least. Okay, here's kind of a more of a close-up view. There's our top LED in our cupola on our modified caboose. And here it is over here on our other one. And just kind of tried to give you an idea how bright it is on the inside. If I come over here, get that out of the way here, you can see, you can barely see that capacitor that I painted in there. So really, it's kind of hard to see in general. But it is back up in that general corner. Yeah, there it is. There's back. But it's kind of hard to see back up in there. Of course, this one, like I said before, has the smoke unit in it, so it's got some other stuff up in there. There, that's a pretty nice view. Let's see if we can't try that over here. Come over here. You know, it doesn't look bad. I apologize for the shaking. But all in all, I think I could have made that one brighter. Okay, so we're all done. I'm happy with how this turned out. Like I said, learning process. But you know, it works. My light won't flicker as I go down the track anymore. That was the main goal there. If you have any questions, if I didn't explain something you'd like to know something I did, just make sure you leave that down in the comments. Thanks for watching.
Union Pacific 3989 here. Am I clear to make a move? Over. Yes, 3989. Take the green. Over.